Unit 5, Understanding Prints. A print shows a series of views that give the welder an exact shape and size description of an object. Additional information necessary to make or assemble the product is also included on the print. The best way to read a print is to mentally break it into smaller parts. First, try to look at the shape of the part with the dimensions and notes removed. Second, try to determine the overall size of the part so you have some understanding of how big or small the part is. Third, look at the title block for information about the title part, material, scale, tolerance requirements, and other general pieces of information. Finally, read all of the notes on the drawing. Multi-views. Most prints are in the form of multi-views. Multi-view drawings are needed when more than one view is required to give an accurate shape description of the object. On most prints, the object is drawn in the operating position. The views are arranged on the print in a systematic manner accepted as standard throughout industry. For example, in Figure 5-1, the top view appears above the front view. The right side view appears to the right side of the front view. This makes it easier for the welder to merge the views in his or her mind and to form a mental picture of the object. In developing the needed views, the entire object is normally viewed from 6 directions: front, top, left, left side, right side, rear, and bottom views. In Figure 5.3, the same object is viewed separately from these various directions of sight. To obtain the views, think of the object as being enclosed in a hinged glass box. Study Figure 5.5 carefully. Imagine the views are projected on the sides of the box. The top view of the object is seen on the top of the box, the front view on the front of the box, and so on and so forth for the remaining views. This technique is called orthographic projection. It permits a three-dimensional object to be described on a flat sheet of paper having only 2 dimensions. As can be seen, at least 6 views will be developed. Not all of them, however, are needed. Only those views required to give an accurate shape description of the object are included on the print. A view that repeats the same shape description as another view is not used. In Figure 5.6, the principal views commonly shown on a print are front view, top view, and right side view. In the United States and Canada, all engineering drawings are drawn in third angle projection, with the object drawn as viewed in the glass box and the views projected to the 6 sides of the box. The projected views are drawn to resemble views when the box is opened out. The top view is always directly above the front view. The right side view is always to the right of the front view and in line with it. The left side view is always to the left of the front view. Drawings used in European countries are sometimes drawn in first angle projections, with the object drawn as if it were placed on each side of the glass box. Figure 5.7 shows both third angle and first angle projections. Compare the two. The main differences include how the object is projected and the arrangement of the individual views on the drawing. The type of projection angle is usually identified on the drawing by ISO, International Organization of Standardizations, symbols figure 5-8. Views. The true shape and size of objects have angular or slanted surfaces cannot be shown using the principal top front side views. The true length of the angular surface in Figure 5.9 is shown on the front view, but this view does not show its width. The true width of the angular surface is shown on the top and side views, but neither view shows its true length. An additional or auxiliary view is used to show the true shape and size of the angular surface. Figure 5-10, because of its extensive use of angled surfaces, sheet metal and press brake drawings often use auxiliary views. The auxiliary view is always projected at right angles, 90 degrees from the principal view on which the angular surface appears as a line. Quite often with auxiliary views, it is possible to eliminate one of the principal views, as in Figure 5-11. To avoid confusion and unnecessary sections of the part, some auxiliary views are drawn as partial auxiliary views. Only the angular surface is shown in the auxiliary view, and brake lines indicate where part of the view was removed. Sectional lines. When an object is relatively simple in design, its shape can be described on a drawing without difficulty. For a complex object with many features obscured from view, however, it is often not easy to show its internal structure without a jumble of hidden lines. In Figure 5-13, the drawing is hard to understand and interpret. Sectional views or sections permit the true internal shape of a complex object to be shown without the confusion caused by a myriad of hidden lines. A sectional view shows how the object would appear if an imaginary cut, known as a cutting plane, were made through the object perpendicular to the direction of sight. Shown in Figure 5-14, a section or portion of the object between the eye and the cutting plane is removed or broken away to reveal the interior features of the object. This makes the shape of the object more understandable. Figure 5-15a shows the exterior surface of a pin. Notice that the interior features in Figure 5-15b are easier to visualize if a full section view is provided. A sectional view shows how an object would appear if an imaginary cut were made through the object perpendicular to the direction of sight. This allows interior features to be seen without the confusion of many hidden objects. Cutting plane line. The cutting plane line indicates the point from which the imaginary cut of the section is taken from the part. Figure 5-16, the arrows at the end of the cutting plane line show the direction of the sight for the viewing of the section. Three forms of cutting plane lines are accepted for general use. Sections are usually identified with bold capital letters, A-A, B-B, etc. if they are moved to another position on the drawing. Section lining, sometimes called cross-hatching, represents the type of exposed cut surface of a section. The American National Standards Institution, or ANSI, has recommended the symbols for section lining shown in Figure 5-18. The symbols depict the different types of material specifications. General purpose section lining, such as cast iron, is usually used on drawings when exact material specifications are located elsewhere on the print. Thin section. A thin section, or a section not thick enough for conventional sectional lining, such as sheet metal gaskets or etc., is shown as a solid black line. Full section. A full section is shown when the cutting plane line passes entirely through the object. Figure 5-20, the interior features of the object are revealed. Half section. Half sections are primarily limited to symmetrical objects. The shape of one half of the interior features and one half of the exterior features of the object are shown in the half section. Figure 5-21, the cutting plane lines are passed at right angles to each other. 1/4 of the object is removed and the half section view is exposed. Revolved section. Revolved sections rotate or turn the cut section 90 degrees. They are primarily used to show the shape of such things as spokes, ribs, and stock metal shapes. Removed sections. A removed section is used when it is possible to show the sectional views on one of the principal views, such as figure 523. The section is moved to a new location on the print, allowing it to be enlarged for clarity. Offset section. The offset section is used when a single straight cutting plane cannot show the needed information, such as figure 524. In this case, the cutting plane line is stepped or offset to pass through these features that lie in more than one plane. Broken out section. A broken out section is used when a small portion of a sectional view will provide the necessary information. Break lines define the section. Conventional break. A long, uniformly shaped object is sometimes difficult to present in a scale large enough to show its details clearly. A conventional break permits elongated objects to be shortened so a large enough scale can be used to present details with clarity. Sections through webs and ribs. Webs and ribs are added to some objects to increase the part's strength and rigidity. In figure 527 shows how ribs and webs are represented in sectional views. Rules on reading prints. There is no best way to read a print or drawing. Most welders come up with their own method. The following rules are suggested to help you get started. Eventually, you will develop a method best suited to your own needs. Carefully review the print. Study one view at a time. Identify surface limits and lines that describe the intersection of surfaces. This will help you to visualize the shape of the object. Establish sizes from the dimensions. Review the other information, notes, title block, revisions, etc. on the print. Determine what your responsibilities will be in producing the object and the sequence you will have to follow in performing the operations. Do not be afraid to ask for help if you do not understand something on a print. A mistake caused by not understanding something can be very costly to your employer and may cause injury to someone using the product at a later date. Practice print reading until it becomes second nature to you.